Hello. In this video we are going to study how to configure the static routing using a packet traces. Static routing. Okay, for implementing a static routing you will have to first design a network. So for designing a network we will require some routers here. So we will drag routers from the networking devices available. So just drag these devices like this. Then next we will require a switches. So select the 24 port switch from here and drag the switches, one switch here and one switch here. Okay, after that we will require the end devices. So drag the end devices PC here, one here and one here. Okay, so these are the devices that we have dragged. Now next we have to connect these devices. So for connection of the devices we will require either straight cable or the cross cable depending on our requirement, whether we want to connect the similar devices or the different devices, or you can select this automatic cable that will automatically choose the cable. Okay, so select the automatic cable, then connect the devices so that you can connect this within a lesser time. Okay, after connecting the devices, you have to connect the router to router. So for router to router, don't use the automatic cable, rather use this serial DCE cable. So select this serial DCE cable and it will ask for the interface. Now for serial DCE cable, select the serial interface. So here there are two serial interfaces, serial 20 and serial 30. So we are selecting serial 20 from first router to the second router. Okay, so this connection we have made for the static routing. Now next we will try to assign the addresses, because for communication in the network you should have the IP addresses or address to each of the device. So it is very much required to assign the IP addresses. So now in this configuration we have three different networks. Let us mark these networks. So which are these networks? So first network is let us mark fill color, select color yellow. Okay, so this is your first network starting from here to this interface of the router. Then next we will assign or mark with a different color so that you will clearly understand which are the networks that we have to design. So this network starts from this router to this router. And third network, so we will assign different color to this third network, light, let us say this as a color, or which color, pink as a color we will assign. So this network is starting from this router to here. Okay, so these are the three networks that we have to configure. Okay, now we will try to assign the IP addresses. So IP addresses, we will try to assign the IP addresses. So IP addresses for this network, for this PC and this interface of this router, we will have the IP addresses in the range of 200.0.0.0. Okay, so this is the IP address, network address for this router. Now next network address for this router we will try to assign in the range of let us say 100.0.0.0, and final network we will try to assign the IP addresses in the network or from the network. Let us take one class B network. Let us have 150.0.0.0. So these are the three network addresses we have taken. This one from class C, this one from class A, and this one from class B. Okay, so you have to assign the IP addresses to the end devices now. So we will just mark the IP addresses that we are about to assign. So we will assign here 200.0.0.2 for this network. For this network we will assign 200.0.0.3, and finally one more interface is remaining, this pass Ethernet interface. To this interface dot 0 dot 0 dot 1. So always assign the first address of any network to the router interface, so that will be easier to uh, uh, understand which address is given to the router interface. So we are assigning the 200.0.0.1 to this interface. Similarly, for this network, first address will be given to the router fast Ethernet interface, so it is 150.0.0.1. Then this PC will have 150.0.0.2, and finally this PC will have 150.0.0.2, sorry, 3. So 1, 2 and 3 we have assigned. Now remaining network, this 100 network, it has two interfaces, serial interface and this serial interface. So IP addresses we are about to assign is 100.0.0.1 here, and one more IP address here to this serial interface, 100.0.0.2. Okay, so these are the range of the IP addresses that we are about to assign to the end devices. Okay, now next let us assign the IP addresses. So this first PC, okay, now we have assigned the IP addresses to the end devices, that is PCs. Now next task is to assign the IP addresses to the routers. So router has two interfaces, one is fast Ethernet interface, that is this, and one is serial interface, that is this. And we have to assign two different IP addresses to two different interfaces. So select a router, go to configuration mode and select an interface to which you want to assign the IP address. So first we will assign this IP address to fast Ethernet interface, because this is showing FA00 here. So we will select FA00, and the IP address to this is a 200.0.0.1, 200.0.0.1, and the routers are by default in the off condition. We have to start these routers, so check this box to turn on the router. Okay, so you can see the commands, those are typed for the interface routers. Now next interface that we have to select is the serial interface. So select the serial interface here, serial 20. So serial 20 has the address as 100.0.0.1. So turn on the device, set the clock rate and assign the IP address 100.0.0.1. Okay, so these addresses we have assigned to this routers. Now similarly select the next router. It also have the two addresses, which are those. This 150.0.0.1 to fast Ethernet interface and 100.0.0.2 to serial interface. So assign the IP addresses, go to configuration, first fast Ethernet 150.0.0.1, 150.0.0.1 and subnet, sorry, 150.0.0.1. Okay, so we have assigned the IP address to fast Ethernet interface. Next is serial 100.0.0.2. So serial interface. So for serial interface, don't select the clock rate. For the first router we have selected the clock rate, but for the next router don't select the clock rate. So you have to select the clock rate where clock is showing. So on this router clock is showing, but on this router clock is not displayed. So wherever the clock is displayed, you have to set the clock rate at that end only. Remember, you have to set a clock rate to the router serial interface where clock is shown or clock is displayed. Here clock is not displayed, so we will not set the clock rate. And the IP address we have to assign is 100.0.0.2. Switch on. Okay, now try to send the packet from source to the destination. Let us take, we'll test it in the real time mode. So we will have the faster testing. From this source to this source destination, it is showing as a successful. Then we will try to send another packet. Let us delete this packet or this scenario. send the another packet from this source to this destination. So now in this case it is showing that packet is failed. Okay, now when a packet is failing, turn on the simulation mode and see what exactly is the problem that packet is getting failed. Okay, so select a source machine, select a destination machine and play. So it is going to a switch, which is correct. From switch it is going to a router, which is also correct. But from router it is somewhere getting lost in the network. So this particular is getting failed because of that. Okay, now next task we have to take care of assigning the routing paths to this router. It is very important to assign the routing paths to this router, otherwise you can't send a data from this network to this network, because these are two different networks. This PC is in the 200 network and this PC is in the 150 network. So for their communication it will require to have a routing path. So routing path we will require to set. So for setting the routing path, go to a static routing, static, and add the network which this router doesn't know. This router we have to add a network which this router doesn't know. So this router has the one interface from 200 network, one interface from the 100 network. So these two networks are known to these routers, but this network is not known. So we have to assign this IP address, network address of the network which is not known. Mask is class B address, so 255.255.0.0. And next up, this router will transfer a packet to this interface, serial interface. So we have to assign the address of serial interface to which packet will be forwarded, 100.0.0.2. 100.0.0.2. Okay, so for adding the routing information about this router, what we have done, we have added a network which is not known, its mask, and the next stop. Next stop means this router will by default will forward the packet to this interface. So that interface address you have to provide. So let us add this network and repeat the same task on the second router. So this second router doesn't know about which network, 200 network. So static network 200.0.0.0 mask class C network, so 255.255.255.0, and next hop is this interface, serial interface of the first router, so 100.0.0.1. add. Okay, now this routing table is complete. After completing the routing table, go to real-time mode and test the packet. So this as a source, this as a destination. So it is failed again. We will try one more time. Source and a destination. So it is getting failed. So why it is getting failed? Because we don't have configured the gateway for this machine. So you should configure the gateway. So what is gateway of this machine? The fast Ethernet interface. So what is gateway? 200.0.0.1 is the gateway. We had forgotten to assign the gateway. So assign the gateway. Similarly, we will assign the gateway to this router as to this end device also. Its gateway is 150.0.0.1. So gateway is more often the first address in the network. So this network is 150.0.0.0. So its first address is 0.1 here. So we have assigned the gateway to these both the device end devices. We will again try to send a packet, source, destination. It is failed again. Let us try one more time. Source and destination. So now it is successful. Okay, now if you want to check that in the simulation mode, you can check simulation, source and a destination, play. So it will go to switch, from switch to the router. In the router it will extract the packet information, will find the routing table and will forward the packet based on the routing table. So second switch, from second switch it will go to the second router to it will go to the desired network, and from desired network it will be delivered to the desired destination finally.